Hi, this is Craig Stocks here for Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And today I want to talk about this image of the Running Man Nebula that was captured in a combination of RGB plus HA. And we'll look at that from start to finish, from capture through PixInsight and Photoshop. So let's start by looking at the end result. So the goal here is this image of the Running Man Nebula. It's in a combination of RGB plus HA. And I did capture oxygen and sulfur as well. And what I found was I felt like I got the most interesting image with just RGB and HA. And that may be because this is really a combination of a reflection nebula, which is best captured in just simple RGB. And you can see all of the bright dust here that's reflecting the light from the nearby stars. And you can see a little bit of red in the background from the HA. But when we shoot with a hydrogen alpha filter, it appears to cut through a lot of that dust, and we can see a lot more detail in the fine filamentary structure in the background, and this real bright ball of HA in the center that's lurking behind the RGB reflection nebula. And as I always do, I like to use a starless workflow, so I use Russell Croman's Star Exterminator to extract the stars and keep those on a separate layer so I can put the three pieces back together, and that gives me the RGB plus hydrogen alpha for that all that hydrogen detail, and then the stars on top. So let's start at the beginning with how the data was captured. And the first thing we'll look at, I've already connected to the remote telescope. So this window now is looking at the remote computer on the observatory about 60 miles north of here. And I use Voyager as my sequence manager for the night. And so let's look at the sequence that I set up for the Running Man Nebula. So I'll open the sequence editor, and we'll open the Running Man. And so this is the sequence that I used, and I apologize, it seems like the windows just keep getting smaller and smaller. But I had the sequence configured to shoot oxygen, sulfur, hydrogen, and then red, green, and blue. And I was using 600-second exposures for the narrow band, which is my standard, and then 300-second exposures for red, green, and blue. And I actually inadvertently used 200 seconds for the blue, but that, as you'll see, that really wasn't a problem. And each one of these is configured to repeat 3 or 4 times, and then this whole sequence is set up to repeat 6 times, which the Running Man this time of year doesn't really get high enough that it's in position to be imaged until about 3 a.m. So I really only have about 2.5 or 3 hours of imaging time on the Running Man each night. So this was the configuration I set up, and this was scheduled to start around 3 a.m. So with that, let me exit out of here, and we'll go next into PixInsight. So let me open PixInsight. Now, I've already run this, obviously, but I will show you how it's configured. So the first thing I always do is go through Process, Image Inspection, Blank, and I would open up the data from the Running Man. So let's just look at, there's not much there. Let's look at the night before, from the 16th. That's a little bit better, so we'll open this. And what I do in Blink, it gives you a screen stretched preview, and I basically just step through looking for any subs that have, the wind caught the telescope, or for whatever reason are substandard that I want to completely take out. And what I'll do is move, so this hydrogen or this oxygen, for instance, doesn't appear to have much data. So what I would do is go to the move icon in the blank window, and it just asks me where I want to move it to, and I keep a folder named rejects, and I just move those bad subs into the rejects folder. What that does is take it out of the folder that I want to leave only good data in. Once that's done, and I've gone through every night and all the subs and have all of the less than good subs taken out, next I go to WBPP. So we'll open WBPP, and this is kind of a standard sequence I do over and over. In fact, you'll notice I've got icons over on the right, and for the most part I just work from top to bottom down the icons. So the first thing I'll need to do typically is reset WBPP, and I always do it from the settings of the last session and clear all files. So we'll go to the plus lights at the bottom. The tabs at the bottom add data. The tabs at the top show you those individual pieces. So for instance, this is the lights tab. If I want to add lights, click on plus lights, and this is the folder we were just looking at. Click open, and I actually have more from other nights, so we'll do that again. This was for the 16th, the 17th. There's some more data. We'll add those. We'll plus lights again. Looks like the 15th, we had quite a bit that night. I just selected one, clicked Control A on the keyboard to select all, and just keep going until we have enough data selected that we have enough to run. And you'll notice there's only a couple oxygen and one sulfur. It needs at least 3. So right now the oxygen sulfur will not be enough to integrate. And as it turns out, we don't use that anyway. We also need to load our calibration frames. And you can go through one by one and load darks, biases, and flats. What I do, you also can load an entire directory. And what I've done is put all of my calibration frames in one directory. So I can go to plus directory and go to my calibration folder, and this is the mono combined. And if we look at what's in there, there's actually 3 folders, one for bias, darks, and flats. But if I load the mono combined directory, select folder, it will actually go through, sort out what kinds of files those are, and now you'll see the flats, darks, and biases are all fully populated. And there's usually some extras in here. For instance, I don't think I have any 120-second exposures. I can choose to remove these by just selecting that and then choosing remove selected, or you can leave those in. It doesn't really cause a problem. Once everything is loaded, you go to the calibration tab, and I usually start by setting a pedestal level of 300 and apply that to all light frames. And what that means is I've selected one row of lights, in this case the hydrogen. So I'm applying that to just this row of hydrogen. When I click on apply to all light frames, now it applies that setting to all rows. You'll notice the blue, and I mentioned that I inadvertently had that set for 200 seconds, and I don't have a 200-second dark frame. But on this one, and that's why we have this little warning symbol, I can go up to calibration settings, and if I click optimize master dark, now it's happy and it will use the bias frame to create a master dark that it can use for that. The last thing I'll need to do, since these are all monochrome, we don't need to do anything with the color filter array or CFA settings. So the last thing we need to do is go to the registration reference, and I usually will have that set on auto, and just navigate to the folder, and I always have a swap files folder where I capture all of the temporary files, and at this point it's ready to run. So I've already run this, but what I would do is click run, let it run for 20 minutes, half hour, however long it takes. And when it's done, now we can load the master lights that were created, and save those so that they're ready to work on in Photoshop. So let's start with the RGB. So I will just double click here on the background to bring up the file open dialog. Here's our swap files, Running Man, and I'm in the master folder. That you get with monochrome, you get calibrated, logs, master, and registered. Master is where all of the results come from WBPP, and what we want are the red, green, and blue. So, and in fact, here's the blue, green, and red of the 300-second exposures. So let's open that. Now, the first thing I need to do is combine these into an RGB image. And to do that, I'm going to use channel combination, and that's also the first one in the icons over on the right. These are just saved by opening the process icon. So for instance, you could go to process, all processes, channel combination, and get to the same place. And if you want to save this as an icon over here, you can just grab it out and save it as a process icon. You can edit the icon identifier and name it something like channel combination. I've already got one with that name. You can't have spaces, but you can have underscores. And then drag it over here, and then at some point when you don't have any other images open, save a blank project with all of these icons, and then when you start PixInsight, just load that blank project and you'll get all of these icons loaded for you. So what we need to do now, we're in channel combination and we want to create an RGB image. So obviously we're going to match up the red, green, and blue files. So two ways to do it. I can open the folder here and select red because this is the red channel. I can also grab over on the left hand side, there's a tab that has the file name, and you'll see the cursor changes to a little arrow. I can drag this over and watch when I hold it over the folder here. This is the green. So now we can just drop it in place. I can grab the blue, drop it in place, and now we have our red, green, and blue views selected for the channel combination. Click the solid circle in this case to apply this, and it creates a new image, which is the red, green, and blue combined. I can now close the process, and I can in fact close the individual red, greens, and blues because we're done with that. Let's put a quick screen stretch on this just to preview what's there. The file is still linear at this point. That's what it looks like, and doesn't look very good. So the first thing I want to do is run dynamic background extraction in subtract mode, and again I have an icon saved for that, and that icon even has the samples already predefined around the perimeter. So I'll execute that, and this will clean up that color cast significantly, and we'll update the screen preview, and that starts to look pretty decent right there. Next I would run spectrometric color calibration, spectrophotometric, and again I've got a saved process icon, and I can just drag that onto the image, and this may or may not run. It's been having trouble with not having enough stars that it could find, and it could be because I'm using a fairly small subset of the Gaia catalog, so it may not have enough stars to be able to actually do the color calibration. No, it doesn't. It errored out. So we'll just take this as it is. Next I'll run Blur Exterminator. Blur Exterminator is an AI program from RC Astro, Russell Croman's AI products, and there's actually 3 products that I use extensively: Blur Exterminator, Noise Exterminator, and Star Exterminator, and you'll see each one in action. What Blur Exterminator does is it does deconvolution sharpening, which takes the natural blurriness that occurs from a combination of the atmosphere shimmering, problems in the optical train of the telescope, problems in tracking and so forth, and it uses artificial intelligence to deduce the convolution point spread function. In other words, mathematically, what's the shape of the curve that blurred it, and then it applies the inverse of that to unblur it. I've seen people say, oh, it takes Hubble data and replaces your data. It doesn't do anything like that. What it's doing is using artificial intelligence to determine the deconvolution parameters, which tend to require a lot of judgment and trial and error, and then it applies those in a classical deconvolution mathematical process. So there it is with the deconvolution applied, and one of the things you notice is the stars get smaller. Now I'm ready to stretch the image, and I do this real simply using the screen transfer function, and you have to also use the histogram transformation function in order to apply it. So we'll update the stretch by clicking on the nuclear button here, and this will give us an updated preview. Not much changed. And I usually adjust this a little bit by zooming into the adjustment carets, and typically I'll wind up darkening the darks, and sometimes I'll brighten the brights a little bit. And then once that's done, you have to use the triangle to drag the data or the shape of this curve that the screen transfer function arrived at, and drop it down here on the bottom bar of the histogram transformation. And when I do this, watch the straight line that goes across the histogram transformation function. You see how that changed into a curve. That shows me that I copied the shape of the curve from the screen transfer function to the histogram. Now I can apply that, and the image turns all white because we're now looking at a brightened image, artificially brightened image of an image that's already been actually brightened. So we need to turn off our preview stretch, and we can do that with the leftmost icon. So now we have an actual stretched image, and this is obviously our RGB image. The last thing I do is apply noise exterminator and star exterminator. So we can grab noise exterminator and drag that onto the image, and it will run. And again, this is using an artificial intelligence process to understand where the noise is in the background but not in the stars. So it doesn't destroy stars, it doesn't disturb the fine detail. All it's doing is cleaning up the noise. And lastly, we'll take Star Exterminator, and in Star Exterminator there's a couple settings we want to be sure we have. We want to generate the star image, in this case because we want these RGB stars, and we want to use the unscreen process to remove the stars. Once that's ready to go, we can apply that. And if you're able to use an NVIDIA graphics card in your computer, in a Mac you probably are already getting the hardware acceleration. In Windows, if you have an NVIDIA graphics card, you can install drivers in order to use the graphics card processor to greatly speed up the artificial intelligence application. And so in this case it takes about 30 seconds to run on my machine. And when it's done, we'll have two files. We'll have a starless version of the nebula, and then we'll have the stars on their own layer. The last thing I do on the stars, I know I've said last a couple times, I run a combination of curves just to increase saturation, and then I run SCNR to remove green. And now these stars are ready to save. So I'll save these as a 16-bit TIFF of just the stars. And then I'll also save this starless version of the background as a 16-bit TIFF. Next, we'll open the HA. So here's our hydrogen image. I'll click Open. And again, we'll do a screen stretch just to see what this looks like. So this is our hydrogen data, and it's interesting how well the narrowband filter picks up just the hydrogen and it kind of cuts through that reflection nebula. So that dust that's reflecting starlight just kind of disappears. So we don't need to run dynamic background extraction, although we can if we want to. If we think there's a gradient here, we can run dynamic background extraction, and that will even out the illumination across the frame. Next I don't need to run color calibration, so we'll run blur exterminator, and that will crisp up the fine details. It will also make the stars a little bit sharper like it did before. So this becomes just somewhat repetitive of what we did with the RGB image. And again, this will take about 30 seconds to run, and when it's done, you'll see the stars suddenly get a little bit smaller, and you may notice the details getting a little crisper if you're zoomed in enough to really see the details. But the main thing you'll see here is the stars getting smaller because they're getting a little bit sharper. Now we'll apply the stretch, and again we'll use the screen transfer function, and I will probably darken the darks a little bit and perhaps brighten the highlights a little bit, so it's a little bit more of a stretch. Drag that down to the histogram transformation tool, apply that, turn off the screen transfer, and then lastly we'll apply noise exterminator and star exterminator. I'm applying these one by one because I'm showing you the steps. You'll notice there's some other process icons here. A lot of these are actually process containers. And what a process container does is let you take two processes, such as noise exterminator and star exterminator, and put those together into one icon, so you can run them both sequentially just by using the process container rather than the individual process. It doesn't really save the computer any time, but what it does is it starts a sequence of processes running so that you don't have to be here step by step. You can go off and check your email or get a drink or whatever. There's our finished starless HA image, so we'll save that as a 16-bit TIFF. And at this point we're done with PixInsight, and so we'll go to Photoshop, and you can kind of see now where these three images came from. We created a starless RGB image, we created an image of just the hydrogen alpha, and we created an image of just the stars. And if we look over here on the right, let me zoom in on this, and we'll turn off the text, and I'll turn off these other layers. So here's our finished combined image, and let's look at the components. I've got a solid black background. Next is the HA, and if I turn off the others, you'll notice that this is red, and it's red because I'm using only the red channel from the HA. Next is the RGB, and it looks just like it did before. What makes it combined with the HA is the fact that this layer group is in lighten blending mode. And what lighten blending mode does is it takes any place where this layer is lighter than what's below, then this replaces what's below. If they're the same or darker, then what's below continues to shine. So for instance, around the perimeter where things are really dark in the RGB image, the red from the hydrogen alpha shows through. And that is kind of the natural color of hydrogen alpha. And then lastly, the stars are on top. And if you recall, when we removed the stars, we clicked a box that said unscreen the stars. So the proper way to put the stars back in is through screen blending mode. So we have just plain blending mode, we have lighten, and then we have screen. So let's go through each one of those quickly from scratch. So I'm going to open the files that are saved. I'll go to File, Scripts, Load Files into Stack, and this is where we load those processed TIFFs that we created in PixInsight. And I'll browse and navigate to the folder where I saved those. And those should be right here in the Running Man folder. And so here's our red, green, and blue starless. Here is the stars. And here is the hydrogen. So let's load these three layers. Hopefully these are the right three. And when you choose load layers and stack, what happens is the Photoshop is loading those three images, and it loads them as individual layers in one document. So now in the layers palette we have our starless image, we have our stars, and we have our hydrogen alpha. So the first thing I'll do is rotate this so the Running Man is running rather than doing a headstand. I'll go to image rotation 90 degrees clockwise. There's a couple things that we can clean up on this layer. So I'm going to just grab the remove tool, and normally you might want to do this on a separate layer so that it's non-destructive. You can do that by adding a blank layer right above the layer you're working on. And as long as there's nothing else visible, in other words, these other layers are not visible right now because the RGB layer on top is hiding everything below it, I can choose the sample all layers. And now when I sample on this layer, if I'm like this, it's actually changing the base layer. So I've actually changed pixels, and that's destructive, and that's something generally you don't want to do. So let's undo that, and instead we'll target the blank layer. I'll do the same thing. I'll paint over the thing that we want to remove. What it's doing now though is it's putting the removed part on the blank layer. So I can turn the blank layer on and off and basically undo these changes. And I'll just quickly grab a bigger brush and remove some of these. These are bright areas where the stars left some artifacts from the star removal, and I'm just very quickly cleaning these up. In reality, you'd want to take a little bit more time. We also have a little bit of lens flare coming in here and over here. I'm going to fix that by adding another blank layer. I'll put it in soft light blending mode, and that lets me paint with a brush. I'll just grab the brush tool. I want to darken this, so I'll paint with black, and so I'll reverse the foreground and background colors, and I want to paint at about 10% opacity, which I can move the slider, or I can just tap the one key on the keyboard and that will select 10%. And painting with black will darken, painting with white will lighten. And notice when we look through here, you can still see the detail behind it. It's just that the lens flare made it a little bit too bright. So when I paint with black, and it may take a couple passes over it to clean that up, I'm darkening the lens flare, this glare from the bright lights, but I'm not actually changing the underlying data. I'm just allowing the data to be revealed. So I'm just repeatedly going over this at 10% opacity, and I'll do the same thing over here. We'll just darken this so that it blends in, and we've got a little bit here, some here from a bright star. If you're not sure if it was a bright star or if it's something real, you can always turn the stars on and off to preview. But we'll say that's, got some down here at the bottom. Use the left and right bracket keys to make the brush bigger or smaller. And again, we'll just go over this to, we're not changing the detail, we're just darkening that lens flare. Maybe something like that. Now I want to take these three layers, the starless layer, the layer where we did the healing, and the layer where we did the burning and dodging, and I'm going to put all three of these into a group, which I'll do by selecting all three layers. I'll do a Control G on the keyboard to put those in a group. double click to change the name to RGB. And at this point we're kind of done with this for now, so we'll just turn it off. We've got the stars layer next. Again, I'll drop it into a group and double click to change the name to stars. And remember I said we want the stars to be in screen blending mode. Since it's in a group, we want the whole group to be in screen blending mode. And so when I click the drop down for the blending options, I'll move down to screen, and notice now we're seeing the stars overlaid on top of what's below, which is the HA layer. So I'll close this, and I'm going to move it up to the very top of the layer stack. So at this point we can turn the RGB back on, and we have an RGB image with stars, just like we'd like. Let's turn both of these off and look at just the HA. It's got a couple of artifacts that we need to clean up, so again we'll grab our remove tool and we'll clean up that star removal artifact, and everything else I think probably looks okay. Now in this case we want, I'm going to drop this into a group, Control G, change the name to HA, and we only want red from this. Because the natural color of hydrogen alpha is red. That's the color of an HA filter. What we're actually recording is the alpha emission line. There are other emission lines of hydrogen. The alpha line is the most prominent, at least in visible light. So we want to get only red from this bottom layer. And the way we do that is by using the advanced blending options. You can get to that the long way by going to Layer, Layer Style, Blending Options. And this will bring up this Advanced Blending Options dialog. And you can see here in the center we have red, green, and blue channels. And right now red, green, and blue are all three turned on. And in fact they're all equal, and that's why this appears to be gray. But we want it to be just red, so if we turn off the green and blue, now we have a red image. So that's how we make our hydrogen alpha red. We come back up to RGB, turn it back on, and again it's just overlaying because it's in pass-through blending mode, which is the default for a group. And what we really want to do is just use these bright areas to brighten what's below. So we'll just change this from pass-through to lighten blending mode. Now, wherever the dust is brighter than the hydrogen below, we see the dust, and where it was dark, we see the hydrogen. Turn the stars back on, and that's basically the image. Now, you can spend a lot of time fine-tuning and tweaking and playing with the relative brightnesses. For instance, we might want to come to the RGB and darken some of it a little bit to let more of this hydrogen show through. To do that, we'll just open up the group, and within the layer group, above everything else, we'll add an adjustment layer for levels. And if I darken the darks a little bit, that reduces some of that RGB around the perimeter. And we may want to brighten the highlights a little bit to bring out more of the structure. So at this point then it's just a matter of adjusting to taste to create the image that looks the way you want it to look. It's pretty much that straightforward. Just to recap, we started in Voyager. We looked at how I set up the sequence to capture this data, primarily using the RGB data from a monochrome camera and the hydrogen alpha captured with that deep red hydrogen alpha narrowband filter. We then went into PixInsight, checked all the subs to make sure they were all good, set it up in WBPP and ran that to create master lights. We loaded the master lights into PixInsight and did a little bit of balancing and adjusting. Mostly we did the stretch to turn it from a linear image, which is very dark, into a nonlinear stretched image. We saved those as 16-bit TIFFs, which we were then able to load in Photoshop, and we used the advanced blending options so that we're getting only red from the HA, and we used the lighten blending mode on RGB to let the lighter areas of the reflection nebula show through on top of the HA in the background, and then the stars are at the very top in screen blending mode, which puts them back basically the same way you took them out. All this is non-destructive. We haven't changed any pixels. If I want to undo, for instance, the remove tool, I can do that and bring it back to the way it was. The last thing I would do is save this. You go to File, Save As, and we want to save it with all the layers intact, and those files tend to get pretty large. So the file format you want is large document format, which is Photoshop's native .psb format. Give it a name, save it someplace where you normally save your images, and if you decide later you want to change something, you can reload the image. It'll come back in just like this with the layers intact, all of the settings in the levels adjustment layers, for instance, so you can continue editing it in the future. I hope you found that useful. If you have any questions, be sure to drop them in the comments below. If you'd like to talk to us about hosting a telescope or renting some time on one of our telescopes, you can get in touch with us through the website. Again, that's at utahdesertremote.com. And I hope you have a great day today and an even better night tonight under a clear, dark sky. Thanks.